Hello everyone, welcome to my video. In this video, we're talking about example 5/137. This is an example related to relative motion with a rotating frame. The question is, under the action of a stern and starboard bow thrusters, the cruise ship has a velocity VB 1 meter per second and of its mass center B, and angular velocity omega 1 degree per second about the vertical axis, rotating. And the velocity B is a constant. But the angular rate omega is decreasing at 0.5 degree per second square. Well, the person A is stationary on the dock. What velocity and acceleration of A are observed by a passenger fixed and rotating with the ship? As for any other relative motion with rotating frame questions, the number one priority should be given to identifying who is observing who. Because the equation we're given is the A acceleration or velocity is observing from the rotating frame. And in this case, we are observing person A from the boat. So the boat itself is rotating, is moving. The boat itself, this YBX, this is our rotating frame. And we are observing from the boat, looking at person A. Okay, this is our first priority. And we've identified we are observing person A from the rotating frame. Then next step is to write down the two equations, acceleration equation and velocity equation, and recognizing which parameter is given, which parameter is missing. So there are a lot of information given us to here. Let's write it down one by one. First of all, we have the origin at B. And this XBY is our rotating frame, as I just mentioned. Velocity of B is 1 meter per second. Right. Or, as we have seen in other examples, with the relative motion with rotating frames, it's best to use vectors. Therefore, when we are writing down our given values, just make it habit to write down its vector form as we go. VB is right here, X is here, Y is here, so we'll write down the vector form of VB. In this case, cos 15 degrees I plus sine 15 degrees J. Meter per second. Don't forget its unit. Omega is 1 degree per second. However, degree is not our standard unit. First of all, we need to convert it into radians. 1 degree per second. I'll just do this one by one here. Radius over 180 degree. In this case, we have pi over 180 radius per second. Or, in the vector form, is pi over 180 k radius per second. And apparently we are defining counterclockwise as our positive. In this case, yeah, it is counterclockwise. So our k is positive in this case. We don't have any acceleration of B because the velocity of B is constant. So that gives us AB is 0. But however, the angular velocity is decreasing at a rate negative 0.5 degree per second square. So here I'm just going to do the conversion, pi over 180 radius per second square. negative pi over 360 k radius per second squared. Okay, you notice I kept sine, cosine, and pi here. It's fine if you want to use convert it into decimal numbers. That's fine. Usually, I don't like to do the conversion until the very end, just to number one, I don't need to punch the calculator along the way. And number two is I minimize the roundup errors. In this case, what we want is our acceleration of A and velocity of A relative to B, which is on the rotating frame. So we are essentially want the A acceleration relative and relative velocity, or think this is your acceleration A relative to B, and this is your velocity A relative to B. And recognize B is your rotating frame in this case. It's rotating. Okay, now, given all these, let's see. Writing down the equation, and we should be able to see what parameters that we have and what parameters that we're missing. Relative acceleration equation, VA is VB plus omega cross R plus velocity relative. And this is the one that we want. We've got VA, we've got VB, and we've got omega. And we need to do a quick calculation for the R vector. Okay, R vector is pointing from the center of the rotation to the point of interest, which is A in this case. So R is RBA, or this is the same as A relative to B. Looking at the previous one here, what do we have? From here to here, this is 100 meter in the y negative direction. So our R vector is negative 100j meter, if you want to include unit. So that means this is given as well. The only thing missing is V relative, which is exactly what we want. We're subbing the number here. 0, velocity of B. 0 because velocity A is stationary, as I mentioned. It's standing still on the dock. Plus pi over 180 k cross negative 100j. As I mentioned in class, this kind of question is not that hard to set it up. The hard part is actually solving the vectors. So be very patient. Okay, after solving, I'm saving the time here. You can check your math by yourself. You should get this number. Negative 2.71i, negative 0.259 j meter per second. This is your first answer. The relative velocity when someone is at the rotating boat observing A. Then, let's take a look at the relative acceleration. Relative acceleration is given us by this equation here. Acceleration of A, acceleration of B, plus omega dot cross plus there are a lot of cross products. So your number one step is to make sure you're copying down the right equation from your equation sheet to your paper. Okay, and this is the one that we want. Okay, let's check. Do we have everything? We have acceleration of A, which is 0, acceleration of B, which is 0. This is given. this is given, which is right here. Omega r is all given, and this is what we just calculated right here. The only thing missing in this case is a relative, which is the value that we want. Now, subbing the number here, 0 and 0 for these two, as stated in question. Be very careful when you are copying down numbers. Plus pi over 180k cross, we'll do a cross within the cross first. Pi over 180k cross negative 100j plus, now we are at here, 2 times pi over 180k cross this whole thing. We're just copying down. Let me make a bit more room here. Okay, we're crossing this v relative, that one we just got on top, negative 2.71 k, I. See, it's very easy to even copying down the wrong thing, so be very careful. Plus a relative. Okay, let me just keep the highlight here. This is the one we want. Right, then essentially just summarize everything, simplify this whole thing to get this one unknown that you're looking for. Okay, I wrote down some steps, but you don't have to follow this exact same step as long as you get the same final answer. This the middle step is essentially just helping you to check. This is when I replace all the pi, cosine, sine with values. Equal to 0. Okay, finally, my acceleration relative, A relative to B, 0.864 I plus 0.064 J. Meter per second square, remember your unit. Or if you want to do one further step, you can report as scalar, depending on the question it's asking for. The question is not specifying what value you should report, so I'm just giving you two different options. Either in the vector form or in the scalar form is fine. So your relative acceleration, A relative to B, A standing on the dock, B is on the rotating boat. The people on the rotating boat observing A is having this acceleration. Okay, so in the past 13 minutes, this is a 13 minutes example. We probably spent 10 minutes on solving the vectors. So again, solving vectors, write down the correct equations, be patient. Make sure you're copying down the right number is the key for relative motion with the rotating frames. Thank you for watching. I'll see you next time.